Hey everybody, I know last night I shared some basic observing things that you can do this week for beginners, M35 and its neighboring cluster there next to it. I wanted to share two things going into next week that both a beginner can look at and a more advanced observer can try to take a look at as well. They're both, one's in the constellation of Taurus, one's in the constellation of Gemini. They have to do with one of my favorite topics, one of my favorite things to observe and learn about, which is supernovas and supernova remnants. Both these objects are supernova remnants, and let's get a little bit into what a supernova is. There's two types of supernovas, a type 1A, that's a runaway explosion. It involves a white dwarf star. A white dwarf star is a star similar to our sun, up to about 3 or 4 times the mass of our sun. It can get a little larger than our sun, but at the end of its life it sheds off its outer layers. The core of the star remains a very bright, hot object known as a white dwarf. It's about the size of the Earth typically. It's all the material condensed down into the core, usually carbon, oxygen, nitrogen, oxygen base there. The hydrogen and helium are blown off into a nebulous cloud off the surface of the star after it goes through its red giant phase. And so basically what's happened here is the star has reached the end of its life. It's done burning through its fuel. It's blown off its outer layers. Little cores left, very hot core, and it lights up the surrounding gas and elements that have been sent out, the hydrogen and helium, away from the star that it's sent out. A lot of times, sometimes what happens with these stars is these stars end up as a white dwarf, okay, and their mass is a lot lower than the mass of a star, but it has a companion star, and they're in a close enough orbit around each other that the white dwarf will begin to take off some of that hydrogen off the main star, its companion star. Its companion star is just still going through its life cycle. Okay, it's still on the Hertzsprung-Russell diagram, going through its natural progression in its own life cycle. But this companion white dwarf will begin to take material of it off its companion, stealing mostly hydrogen, and as it continues to steal those elements from the companion star, the white dwarf gets heavier and heavier. When the white dwarf's mass crosses a crucial threshold known as the Chandra-Sakar limit, which is about 1.44 times the mass of our sun, the immense pressure inside the white dwarf causes a runaway thermonuclear fusion. It's like an out-of-control atomic bomb, and there is an explosion where the white dwarf is typically obliterated in a massive explosion, leaving nothing behind. Since they all explode at about the same critical mass, they all have a very similar brightness, which makes them super useful for astronomers to measure distances in the universe. A lot of astronomers call those type 1 supernovas standard candles because it allows them to measure distances in the universe. The second type of supernova is a type 2 core collapse. These types involve a massive single star, at least 8 times the mass of the sun, and the setup is as a giant star spends its life fusing lighter elements into heavier ones in its core, hydrogen to helium, helium into carbon, carbon into oxygen, all the way down. It will eventually it will look like an onion with layers, and I'll put an image in the post of that so you can see it. But when the star will eventually reach a point where the core begins to burn into iron. Fusion can't get any energy out of iron. It actually consumes energy at that point. That's a dead end for this star. At that point, the outward pressure from fusion suddenly stops, and the star's immense gravity wins. And the star implodes in a matter of milliseconds, collapsing the core faster than the speed of sound. So after a few seconds, the core implodes, and then there's a bounce back. The core squishes down to an incredibly dense object. It's usually called a neutron star. It can even become a black hole. And then suddenly bounces back. That rebound sends a shock wave violently outward, blowing the star's outer layers into space. That's called a core collapse supernova. That's what Betelgeuse will do at some point, among some other stars like Arcturus and a few others that are out there in our galaxy. There's some subcategories there, a type 1b and a type 1c supernova. These are just massive stars that have lost their outer layers of hydrogen and sometimes helium before they explode, often because of powerful stellar winds or a companion star blowing them off. Okay? The first object that I wanted to show you here is, it comes from a type 2 supernova, core collapse. It's found in the constellation of Taurus. I have this set up for, you can see here, for today at about 8:56. Could go a little bit later, be a little higher up. But you want to find the constellation of Taurus. You can usually see its horns here. It's usually, the Hyades are here. It's this open star cluster. You can usually see this little triangle here. Follow this all the way down. Okay? And as you come in, you're going to want to go down to the lower one, that end star right there, Tiangen. And as you get there, it's a really easy star hopping in your telescope if you're using your finder. I usually do it this way. I find the three triangles here, and I star hop over to this bright one, and then I just work my way up in my finder. Up here, I'll see a really faint, milky, very faint patchy light. Put the center of my finder on that, put my eyepiece in there, and what comes in is what's known as Messier 1, or the Crab Nebula in GC 1952. The Crab Nebula is what's the remains. It's a supernova remnant. So in 1054, the star here was massive enough. It did a core collapse, and it exploded, and the explosion was so powerful that it was recorded by astronomers in China, Japan, and the Arab world as a guest star that was visible even during the day for nearly a month. The beautiful cloud of glass and dust that we see today is the material that was violently ejected from the star during that core collapse, and it's still expanding outward at tremendous speeds. This nebula that remains is located about 6,500 light years away from Earth. At the very heart of the core nebula is a beautiful structure, and at the very heart of it is a very tiny, incredibly dense object that's called a pulsar that's still powering the entire cloud, kind of lighting it up. Okay. When a giant star explodes, its core was crushed down to a super dense ball of neutrons, a neutron star. This star is only about 17 to 19 miles across, but it weighs more, has more mass than our sun. It's a cosmic lighthouse. The neutron star is spinning incredibly fast. It's going about 30 times every single second. So every second it's spinning 30 times. I'll put in my post, I used to have a link to it. You can actually hear the sounds of it, the sounds of some of the other ones, and I'll see if I can still put that in the links. As it spins, it shoots out beams of energy like a lighthouse beam, boom, 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 okay, that we see as regular pulses of light and other radiation. This rapidly spinning pulsing star is called the Crab pulsar at the heart of the Messier 1 in GC 1952. The pulsar's energy field acts like a dynamo, constantly whipping the surrounding gas and particles into a frenzy, which is what it makes to make the whole nebula glow so brightly, even over 1,000 years later since the explosion. It's one of the most famous objects in the night sky, and it's a crucial laboratory for astronomers because we know when it happened in 1054, and we know that it was a massive star that dies, and we can look at its leftover column pulsar and even continue to study it 1,000 years later. So there's the first object to go for next week once the moon gets out of the way, M1, the Crab Nebula. You'll actually take, if you do this, you're actually going to start to complete my Supernova Remnant observations. The second one, probably a little bit more experienced observer will need to do this. And let's get in here. So let me show you. I'm just going to come out. This is constellation of Gemini, the twins. Here you can see Orion. There's the belt stars. Right now, in the late evening, later in the night sky, the twins look like this. You can see there's the Pollux, there's Castor. Here's the top twin. Here's the bottom twin. Jupiter's right there. That helps you to recognize it. But if you come in and you come in and you come all the way down and you go up, start going up the lake here, you go to the star Propus, you'll see as you come into Propus, if you put a wide field eyepiece in your telescope, you have 8 to 10 inches or greater, I would say 10 inches or greater, you put an O3 filter, a 2-inch O3 filter on a very low power eyepiece and begin to scan around, you can see, you'll find remnants of this supernova remnant, which is called IC443, the JellyFish Nebula, because the tendrils here, here's the head, it looks like the tendrils of a jellyfish, so it's called the JellyFish Nebula. It's actually another supernova remnant. It's a cloud of gas and cloud dust that's been left over after its very massive star exploded. Kind of showed you how it looks like the jellyfish on its side with all the tendrils going down as they stream into space. If you're imaging, it's a great thing to image. I've actually visually looked at this both in a 10-inch, 14, and my 17.5-inch telescopes, and you can see the brighter portions there. Actually, I have a sketch that I'll include in the post on that. It's located about 5,000 light years from Earth in the constellation Gemini, and it spans 70 light years across. Okay? The star that created and exploded a long time ago, astronomers estimate that the supernova happened somewhere between 3,000 and 30,000 years ago. And the JellyFish Nebula is unique because of how the blast wave from the explosion is hitting surrounding space. It's an uneven environment here. The exploded material is not moving into empty space. Instead, it's smashing various types of clouds in its path, which gives it this weird, uneven shape. It's slowing down in some areas. It's hitting a dense, clumpy molecular cloud, a cloud of cold, dense gas, which acts like a wall. The friction shows the blast wave down, slows it down significantly. In other areas, it's really speeding up. It's moving into less dense gas, allowing it to speed and expand much faster, creating those long, wispy tails that resemble the tentacles. Again, I have not seen tentacles. I've just seen this part of the JellyFish Nebula, and with really good eyes and good eyesight and a very dark side, I was able to see some of the filaments that are in here. Just like the Crab Nebula, there's a tiny dense object left at the scene of the explosion here. It's a pulsar. They have found a neutral star. It's rapidly spinning ultra-dense stellar core near the remnant's southern edge. So down in here, there's a remnant. It's a pulsar. It's believed to be the collapsed core of the star that originally exploded a long time ago. This is a challenge object. It's not going to look like a Messier object or one of the brighter objects or planets out there. This is a good challenge to test you. I'd be at a dark side, have a somewhat larger scope. I have a 2-inch wide field eyepiece, and that usually means it's going to be a 2-inch eyepiece. I'd have a 2-inch O3 filter, and maybe I'd take it down to, I usually start 28, 30, and then work my way down to about 20, and then I'll go down to 13, and sometimes to 10, just to see what I can see in terms of filaments and structure in here. It's very faint, so don't think this is going to be a great thing to see. Two supernova remnants that you can see in the winter night sky. Take a chance when the moon gets out of the way. Well worth your time to observe them. Keep looking up. I hope this makes it a little easier for you. And again, I'm using Stellarium, free software, free app. You can use it. Just so you know, I know that in my own observing, I use a program called Sky Safari Pro. I pay for that. But Stellarium's free. You can get to there. You can find all kinds of really cool objects to go after and look at and view here. Again, look up, have a great time. Make sure you're connecting with the universe. Have a great day and a wonderful evening.